Welcome to this presentation of dynamic routing protocols. The dynamic routing protocols is something that we use for the routers to update each other about their different types of network that they are connected to. By default, when we start up a router, it will only know about its own directly connected networks. So if I want to know something about how my neighbor's router networks are configured, well, then I need to exchange this information. We can of course do it ourselves by setting up static routes, but by using a dynamic routing protocols, the routers themselves will exchange information about their networks. So it will be updated. So if something change in some of my neighbor's network, well, then it will be automatically updated in my routing protocol or routing table. It will also use this information to find the best path, because we could have different ways of reaching the same network. But then our dynamic routing protocols will find out which one of them do I choose, what is the best option. And of course, if something goes wrong and a network is no longer available, then this will also be updated. So the dynamic routing protocols are some kind of automation of how the routers exchange information with each other, which is of course something that we want. We divide them into two path types. One of them is the interior gateway protocols, which is something that we use within the same autonomous system, which means that it is under the same administration. For instance, an organization. And we have the exterior gateway protocols that we use to route between autonomous systems. So that could be between different types of organizations, and different types of, specifically autonomous systems. We can, of course, have organizations that are huge and have different types of autonomous systems within the same organization. But we try to put them into groups, and then within the same group, we are using the interior gateway protocols, and between these groups we are using the exterior gateway protocols. Examples, for instance, of the interior gateway protocols are RIP, EIGRP, OSPF, and ISIS. And then, or is this? Yeah, I don't know. And then we have the border gateway protocol, which is an example of the exterior gateway protocol. When we look at the interior gateway protocols, again, we have two different types. We have the distance vector routing protocols, which are the simple ones where we are using a distance and we're using a vector. So it's like if you go in that direction, at some point you will reach this network, and the distance is, how far is it to reach it. We have the different versions of RIP, which is a distance vector protocol, and we have both eGRP and EIGRP, which are the Cisco proprietary protocols that are also considered distance vector protocols. Then we have the link state protocols, which are more complex. The link state protocols have kind of a map, a topology map of all the different routers in their network, whereas the distance vector basically only know about their neighbors. So here we have a complete map, and whenever there is a change, we will send an update, whereas in the distance vector, well, then we will send out typically an update every 30 seconds, for instance, if we are looking at the RIP protocol. So here we send updates even when there is nothing to tell about, whereas in the link state, we are only send updates out when there is a change in the topology. There is also a difference between classful and classless routing protocols. The classful routing protocols is where we do not include the subnet mask. So basically, the classful routing protocols does not know anything about subnetting. And specifically, if we are using a variable length subnet mask, this will not be supported by a classful routing protocol. And they also have problems with the discontinuous networks because they do not include the subnet mask in their updates. Whereas classless routing protocols, for instance, RIP version 2, EIGRP, OSPF, and ISIS, are classful, so they include the subnet mask in their updates. So they will support both VLSM and CIDR for both summarization of networks and subnetting. And of course, all IP version 6 routing protocols are classless. So if you look at them, we have the distance vector routing protocols, which is RIP version 1 and version 2, and IGRP and EIGRP. We have the link state protocols, which is OSPF and ISIS. ISIS, I think, yeah. And when we look at the speed of convergence, the speed of convergence is when we send out an update, how long will it take until all the devices, all the routers in the network are informed about this, and then we, you know, that we all know about everything. And if you look at RIP and and IGRP, they are slow, whereas EIGRP and OSPF and ISIS is fast. Scalability, well, RIP is for smaller networks, EIGRP, OSPF are for larger networks. Use of VLSM, RIP version 1 does not support VLSM because that is a classful protocol, the same with EIGRP. And the way it calculates the best path is very simple in RIP and EIGRP. That's why the resource usage of the routers are low, whereas EIGRP and OSPF are use more resources in the routers to calculate with the best path of the different routes. When you look at how simple it is to implement, well, I think they are all quite simple, but EIGRP and OSPF has more parameters that you can change. So you have more opportunities when you are using these protocols. When the routing protocol finds out the best path, it uses the metric. The metric is a number that will tell us how far away is the network that I want to go to. So the best path of a route is the one with the lowest cost. When we look at RIP, it will only use hop count as the metric. So it will just say that, okay, I will hop twice to reach this network. And if I take another route, I will have to hop 3 times. So that's why I will I would choose the one with the fewest hops. Whereas OSPF and EIGRP uses a more complex metric where you look at the bandwidth, you can look at the delay and the reliability of a link as well. So you will actually choose the fastest. Yeah, and that was the overview of the dynamic routing protocols. Thank you.